Welcome to EDU World Space.
If this sum is divergent and C is non-zero, let's try to show that this series is also divergent. So let's argue by contradiction.
Here's a clean and professionally
So
formatted
let's
presentation
suppose
of
the
the
opposite
calculation
of what
shown
we
in the
want to
image.
show. The opposite of this.
Application of the
Suppose
work energy theorem, WET. From the work
this
energy
sum
theorem, the force F is given
converges.
by F equals frac tex KE, where KE equals kinetic energy, S equals stopping distance. If I'm given for object
Then we
A,
could go ahead and
FA equals
write,
frac
we could go ahead
100,000,
and rewrite this
0.10.
sum
For
since
object
it
B, FB
converges
equals frac
by pulling out the
225,
C.
1500 equals 0.15 tex makes n. And force ratio frac FA, FB
Since
equals
the
frac
sum
0.10,
converges,
0.15 equal fractional result.
this
A
is
box
why we're
frac
allowed
FA,
to
FB. Would you
rewrite
like a
this
PDF
equation,
version
rewrite
of
this as
this
sum in this
explanation?
form. We can pull out the C. However, if this left-hand side converges, that means the right-hand side converges. So this means that this expression on the right-hand side is a real number. Let's call it x. But then we can solve for the sum of an. So we have x over c, but if you divide two real numbers and c is non-zero, that was our assumption, then this is also a real number. But this means that the sum of an converges. That's exactly what it means to converge. Anytime an infinite sum is a real number, that means convergence. However, we are told that the sum of the an is divergent, and this is a contradiction. So let me highlight that contradiction using this blue color there. So the contradiction is that an converges, the sum of an, and that the sum of an is also divergent. It can't be both. Those are opposite claims. Therefore, we've reached the contradiction, and our contradiction arose from this assumption that the sum CAN converges. Since this assumption leads to a contradiction, it means that this statement up here, this assumption cannot be true. So we must have the opposite of this. And the opposite of converging is diverging. Therefore, CAN does not converge, and which we can reword that to say that is, i.e., CAN diverges, and that's exactly what we intended to prove. So that's our final answer.